In the past few weeks, Jason and I have been building something powerful, a LinkedIn scraper tool using Playwright that extracts struct data from both user profiles and web pages. It can grab professional details and company info, always just a username and company name right from the command line. In this video, I'm going to walk you through exactly how to build this step by step. This course is divided into 4 parts. First, how to Playwright works under the hood. Second, traditional HTML parsing using CSS selector and XPath. Third, advanced data extraction with LLM using DeepSeek v3. And finally, how to bypass common anti-bot detection techniques using Playwright. Let's dive in and build a scraper that actually works. First, let's talk about what Playwright is and what features does Playwright have to help us scrape LinkedIn data. Next, we will dive into how Playwright works so you can get a better understanding of its mechanics. So what is Playwright? Playwright is a web automation framework developed by Microsoft. It can simulate human actions like opening a web page, clicking buttons, scrolling down, and filling out input fields, submitting forms, and Playwright can pull out any data from web page and even execute JavaScript. Next, let's talk about how Playwright works. It consists of 3 main parts. First, there's our scraping script, which acts as a Playwright client. Then, there's a Playwright driver built with Node.js, which serves as communication layer between our script and the browser. Finally, at the bottom, we have the browsers like Chromium, Firefox, WebKit. These 3 components work together to make everything run smoothly. In the actual execution of the scripts, these 3 components run as separate processes. Now let's dive in and see these processes in action. Let's switch over to the cursor. First we need to do is we need to install Playwright. Just run this command. You can also use pip install. Once that's done, you need to do is Playwright install. This is going to install browsers for us. Next, let's run this simple scraper and take a look at the Playwright server process we mentioned earlier. Click to run it. As you can see, the script is running. In the terminal, run this command. We can observe that the Playwright server process is started in the background. You can see this process launches a Node.js. By using ls command, you can see the browsers that we downloaded to our local machine earlier. To scrape LinkedIn profile data, the first step is to log in. For that, let me introduce a very useful feature of Playwright, CodeGen. With Playwright CodeGen, it can help us generate code, automatically log into LinkedIn. Let me demonstrate how it works. Open your terminal and type Playwright CodeGen, followed by LinkedIn URL. Enter. A browser pop up along with Playwright Inspector. Any action I take on the browser on the left will automatically be translated into the code and recorded in the inspector on the right. Great! This is complete login code. To avoid login every time we do something later, we need to save login state. Luckily, Playwright gives us a feature called storage state, which allows us to save and restore the login state when the browser starts. This login state includes something like cookies, log storage, and session storage. Now let's take a look at the login code. We need to change the login code to async mode and add the code to save the storage state. Click Run. Open this file. If you can see the content, that means the storage state has been saved successfully. Next, let's try using this storage state. Here's the code where we visit the profiles page and try to extract the name. Let's see if this works. Cool, it works. As you can see, this time we don't need login again. How to extract data? When you are building a web scraper, one of the biggest challenges is accurately and reliably finding elements you need on a web page. Web page can be unpredictable, so how do we handle that? One major advantage Playwright has over other web scraping tools is its auto-wait and retry features. If the network is slow and the element is tricky to find, Playwright automatically waits and retries until it successfully locates the element. This saves a lot of development time and makes your scraper much more stable. When it comes to locating elements, Playwright offers options like CSS selectors, XPath, even locating by text. Today we will focus on CSS selector. CSS is a core web language, and its main job is to find elements using rules like tag names, IDs, and classes. This is how you can select child and descendant elements using CSS selectors. For more complex cases, you can even combine different rules to target elements. Let's take a LinkedIn profile page as an example. Using this ID rule, we can locate the contact info button. Then, with this CSS selector, we can target the person's name, and with this selector, we can find the current company they work for. Alright, next let's try it out with a demo. Open your browser and press F12 to enter developer mode. Then click on the Elements tab. Next, press Command F or Ctrl F on Windows. To bring up the search box, type your CSS selector here. One quick tip, make sure there's only one matching element. If there's multi results, you need to refine your selector. Okay, let's run the code to extract data from a profile page. This bit of code pulls a name, hit run. Now let's extract the current company. Great, that works perfectly too. To get detailed contact info like personal website or email, we need to simulate click on the contact info button first. So we have a program click the contact info button, then find the elements for things like website or email. After running the code, we will see it successfully grab all the contact details. So the way we just did it, by analyzing HTML structure, is a traditional method of scraping data. It works, but it comes with big drawbacks. For instance, if you need to extract hundreds of pieces of data, you have to maintain hundreds of selectors. And if the web page layout changes, your scraper could break, which means you have to update all those selectors. That can get pretty messy. To tackle this, we are going to look at how LLM can be useful for web scraping. In this section, let's talk about using LLM for a web scraper. Imagine LLM as a super smart assistant at a computer, holding a list, that's our prompt, then scan through the HTML code line by line. With a select, copy, paste approach, it extracts exactly the information we are looking for. Let's use LinkedIn company data extraction as an example. We are going to use open source DeepSeek V3 model because it's very cost effective. First, select V3 model and set the output size to the maximum. Choose JSON as output format. This is our prompt, and as you can see, it lists all the data fields we need to extract, and it specifies the output as a JSON. Now we need to copy HTML from LinkedIn company's web page. Select main node, click copy element, paste the HTML into our prompt. Hit run, check the result. Perfect. You can see that the result is exactly what we need. Alright, let's take what we just did and implement in Python. In this scenario, we need the model to output strictly in JSON format. Luckily, DeepSeek V3 has a handy JSON output feature. First, we define the company data model using Pandatic. Make sure all the fields match the ones we listed in the prompt. Then, when we call the LLM API, we set the response format to specify the return type and JSON schema. Next, we use Playwright to get HTML from the LinkedIn company page. Then, we put it all together, make the prompt, and send it to the LLM API. When we run it, we get the same result as we did on Together AI Playground. Great! Let's quickly compare this LLM-based web scraping approach to the old method of analyzing HTML structures. First, this approach doesn't require hard-code rules. Even if the web page structure changes, the data extraction still works, which greatly boosts development efficiency. Second, however, calling the LLM API does have some cost, since each extraction uses tokens. But if you are only scraping a few pages, the cost is pretty small. Next, we will introduce how to use Playwright to bypass common antibody detection techniques, and we will walk through their principles step by step. We will go from a network IP layer all the way up to the user behavior interaction layer. At the IP layer, if you repeatedly request a website from the same IP, you might trigger HTTP status code 429 too many requests. To prevent this, we need to rotate different proxy IPs for our requests. Now let's dive into the HTTP layer. With Playwright's Context API, we can configure the browser environment and headers to mimic a real user scenario. As you can see the code, we can set a user agent, locale, time zone, and other headers to create a more authentic environment. The main issue with Playwright is that it can be easily detected and blocked by antibody technologies, especially when using browser in headless mode. For example, the Navigator WebJava property is set to be true by default. There is a Playwright Python package that can help us solve this problem. Playwright Stealthy extends Playwright by overriding specific configuration to avoid bot detection. Anti-bot system also analyze user behavior. For example, whether the mouse movements and scrolling patterns looks like a human. We can use Playwright to simulate realistic mouse movements and scrolling behavior by using Bezier curves to mimic human-like mouse trajectories, and adding random scrolling pause and other interactions. We can significantly reduce the risk of detection.